Hello everyone. Today we will be doing the tempo experiment. The aim of the experiment is to study the aerobic oxidation of an alcohol using copper 1 or tempo as a catalyst.
And the first thing we need for the tempo experiment is 4-bromobenzyl alcohol that we will measure out. We need about 0.4675 grams of 4-bromobenzyl alcohol, but as you can see, the scale here only reads up to 4 decimal places, so it will be very difficult to get 0.4675 grams. We will try to be as accurate as possible. Then we transfer the 4-bromobenzyl alcohol powder into an Erlenmeyer flask. Then measure out 15 ml of acetone using a measuring cylinder and transfer the acetone to the same Erlenmeyer flask. Since the measuring cylinder measures a maximum of 10 ml, so we take 10 plus 5 ml.
Place the Erlenmeyer flask on a stirrer with the stir bar.
With the heat turned off. We want the solute to dissolve in acetone by stirring. We also cover the reaction setup since acetone is volatile. Then we are going to weigh out 3 different reagents: copper bromide, BPY, and tempo. So that's the copper bromide being weighed out. Transfer the CuBr or copper 1 bromide into a product vial. Next is to measure out 40 mg of BPY, which translates to 0.04 grams. In the same way, transfer the BPY into another product vial. Next reagent is tempo. We will have to measure out 40 milligrams of tempo. Then we transfer the tempo into another separate product vial labeled as tempo.
Next, we are going to add these 3 reagents that we weighed out into the solution that is spinning on the magnetic stirrer. The 3 reagents that are to be added are copper bromide, BPY, and tempo. And we also pour out acetone in the measuring cylinder so as to rinse the vial after transferring the reagents. The first reagent that we add is the copper bromide. Notice the color change of the solution as CuBr is added.
Then we add more acetone into the vial in order to kind of take all the CuBr.
Then we are going to do the same things for the reagents in the other 2 vials. So we transfer the BPY powder to the solution spinning in the Erlenmeyer flask.
Once again, rinse the vial and add the rest. Notice the color change to the reaction mixture in the Erlenmeyer flask. We have one more reagent left to add, that is tempo.
So we do the same thing. We transfer the orange powder into the Erlenmeyer flask.
Once again, rinse the product vial, add the rinse to the reaction mixture. After adding these three reagents dissolved in acetone, we have to add 1-methyl imidazole, 4 drops. One, two, three, four. Notice the color change. After having the reaction mixture stir for about 5 minutes, we connected the air outlet in the fume hood to the mouth of the Erlenmeyer flask using a tubing. This is used to blow air into the solution. As you can see, there is a very rapid change in the appearance of the reaction mixture once the air nozzle is connected to the Erlenmeyer flask's mouth. This is just 1 minute after the air nozzle is switched on. After the air flows for 15 minutes, the air nozzle is disconnected, and as you can see, their color change is much more apparent right now. And the magnetic stirrer is still on, and now at this point, this reaction mixture will be subjected to separation. The magnetic rod is used to take out the stir bar.
Then we add the solution into the separatory flask. And before adding the solution, we need to make sure the stopcock, or which is the bottom tap, is closed.
And we add two different kinds of solvents, one polar and one non-polar. So first we pour 25 ml of DI water followed by 25 ml of pentane. And then, as we have seen before, we cap the separatory funnel and shake it, and then open the tap at the bottom in order to let the gas out. As the solution is being shaken with the two different solvents, as you can see, the color changes. We repeat the shake, release again and again until we no longer hear a hiss from the gas. Then we let the funnel sit in the clamp as shown, and then allow some time for the two layers to separate. One layer will be the aqueous layer and one other layer would be the organic layer. When we see the two layers separate, we take the cap on the top off and slowly and carefully run the bottom tap. The bottom layer, or the one which is bluer in color, is the aqueous layer. So we are collecting that in a pre-labeled beaker. We need to be careful in this venture so as to only drain the aqueous layer and turn the tap off at the right time. Once the aqueous layer stops pouring, the beaker is kept away, and then the organic layer is collected in a separate beaker. Then we will be doing the extraction again in order to extract more contents from the aqueous layer. We use another 10 ml of pentane in order to repeat the extraction process. Once again, close the cap, shake, rinse. Repeat this until there is no more release of gas. After the separatory funnel is rested for about 5 minutes or so for the two layers to separate, once again we collect the aqueous layer and the organic layer separately. The current organic layer can be combined with the previous organic layer.
Next, we will be adding a drying agent to the organic layer. The drying agent can be a magnesium sulfate or a sodium sulfate. So as you can see here, it comes in the form of a powder. The drying agent needs to be added to the organic layer until it no longer clumps.
After the magnesium sulfate is added to the organic layer, we wait for 5 to 10 minutes and then we are going to filter the solution by gravity filtration. And the first thing to do is to fold the filter paper in quarters as shown. And then opening one of the quarters as shown, we place the filtration paper on the funnel.
So using a glass rod, we are going to moisten the filter paper a little bit so as to try to keep it in this specific position.
Next, while holding the filter paper in place, the organic layer is poured into the funnel.
So students should remember that this is gravity filtration and not vacuum filtration that we have seen previously. And this method takes a little while longer because the liquid is going through the funnel by the force of gravity. Notice that there is no sidearm connected to the vacuum tap.
Then in order to retrieve the solutes dissolved in the solution, we try to evaporate the solvent with using heat. This is what the flask looks like when all the solvent is evaporated. We need to transfer the solid into a product vial and get its weight. First thing to do is to measure the mass of an empty vial. Then take the mass of the vial with the product in it. So these are the list of the characterizations that we need to do. We need to measure the mass of the product, vial plus cap and vial plus cap plus product. This you already did. We need to do the IR, and we need to do the melting point, and we need to do the TLC of the starting material and the product. So we will start our next characterization, which is TLC. So TLC we have seen before. We need to first prepare the plate. Measure 1 centimeter from the bottom of the plate on the two sides. Once the 1 centimeter is marked on the two sides, we need to draw a line horizontal from the bottom of the plate. And this line should be drawn as softly as possible with a very blunt pencil, so as to not scrape the plate. Then label two spots on this line. One should be the starting material, or SM, the other should be product. These are the two spots in which we will be marking our sample. So in order to spot on the TLC plate, the samples need to be in their solution form. So here we are taking the starting material and we are dissolving the starting material in the mobile phase. That's the starting material for bromobenzyl alcohol. Then we will use the solvent ethanol acetate and hexane in 1:4 ratio in order to dissolve this starting material. We will do the same for the product.
In this clip, the product is still in the Erlenmeyer flask, so it hasn't yet been transferred. So we'll take a little bit of the product and then place it on a watch glass. We will be dissolving the product with the exact same solvent. Pipette in some of the solvent in a Pasteur pipette and just use just a 1 or 2 drops to dissolve the solutes, the starting material and the product. Quickly use a capillary tube in order to poke onto the little solution that you created and then tap on the TLC plate as shown. As you can see, the TLC plate is absorbing the solution taken up by the capillary tube. We tap on the TLC plate using a capillary tube 3 times or more if needed, and then repeat the same process for the starting material. Before placing the TLC plate in the jar, we need to check the level of the solvent, and it should not be more than the baseline. The TLC plate is placed in the jar and the solvent is creeping up the TLC plate by capillary action. We are going to take out the TLC plate when the solvent font is 1 centimeter from the top of the plate, which is going to be soon. Once taken out, the TLC plate is quickly placed under UV lamp and the solvent font is marked quickly. So we are going to record 3 distances. The first is from the baseline to the middle of the 2 spots, product and starting material, as marked. And the third is from the baseline to the solvent font, as marked. So these are the distances that have been measured using a ruler. The product has traveled 5.8 centimeter. The starting material has traveled 2.4 centimeter. And the solvent font has traveled 7.4 centimeter. So these readings will be used for calculating the RF value. Next is to collect the IR of the product. As we have seen before, at first we clean the stage and collect the background. Wait for 8 rounds to complete. So that's the background and we wait for 8 rounds to complete. Save to a new window? No. Then we place the sample over the hole in such a way so as to cover the crystal. Collect sample, name the sample, click OK, and wait for 8 rounds to complete. Save to a new window, yes. Click on peak, find peaks, and then adjust the horizontal line. Click on print. After you're done, clean the stage with isopropanol and Kim wipes. Next is to take the melting point of the product. As we have seen before, we poke on our product with the capillary tubing until there is 4 to 5 millimeters of the product in the tubing. And then we drop the capillary tube through the hollow plastic tube so as to collect all the products at the closed end. So all the product needs to drop at the bottom at the closed end. We place the melting point tube in the instrument and wait for the sample to melt. We run the instrument really fast until it hits about 70 degrees Celsius, and then it starts melting very quickly. So that was it, guys, for this experiment. We synthesized and characterized the tempo product, and we took the two readings for the mass of the product. So the vial plus cap with the product and without the product. And we took the IR and the melting point, and we also conducted TLC for the starting material and the final product. Before leaving the lab, as always, we need to clean the benchtop and the fume hood. All the glassware also need to be cleaned first with acetone and then with DI water, and then they need to be put away. And if you guys have any broken glass and as well as a melting point capillary tube, you need to put it in the disposable glass container.